Hi guys, it's been a long time because I was kind of busy. Yeah, we finished the last lecture. We finished about the inductor, right? And okay, today we will learn about capacitors, physical meaning and properties. Uh, let's move on. Okay, first of all, I will share the screen. Okay, first of all, capacitor. I already made a dielectric. About insulator compared to what's the differences between them. So you have to watch it first. It's help you guys to better understanding about it. So this part I will not explain about the mechanism of the capacitor deeply. Just quick review. So you guys should watch it. So first of all, as you guys dielectric here, this part, we say capacitor right here. This is symbol. And this middle part, we say dielectric, right? And the dielectric is the same material as the insulator, right? But differences, the purpose is only differences between insulator and dielectrics. So this is capacitor's component. So two part is a metal plate and the middle side is a dielectric. So which means, for example, I make a circuit. So for example, this is a switch and this is R and this is C. And my question is, do you think if I switch close, the current is flowing here? The answer is yes, but as you guys know, it cannot coming through like this. This is bond electrons, so it's a different. The free electron and bond electrons different, right? So yeah, so totally different meaning. You know what I mean? Let's see here. So first of all, oh yeah, I didn't explain about you guys. So first of all, capacitor is prevent or interrupt the sudden change of voltage, but instead the inductor is prevent or interrupt the sudden change of the current, right? This is a kind of totally different component totally. So if you, what I mean is, if you guys understand the inductor, so it will be helpful for understanding capacitor. Think just reverse way. You know what I mean? So what I mean is, look at the here. Let's compare first. And this is a C. This is inductor and this is capacitor, right? But in a DC circuit, in the transient state, no, it's a steady state. We say the inductors, it's gotta be short circuit, right? But instead, the C is open circuit. Why? That's why you guys need to watch previous lectures. So look at that, for example. So this is a transient state, and this is a steady state. So in the current, this is a capacitor, so V, time. So what I mean is the current is, the voltage is not changing like this if we switch close down. you need it like this, right? So as you guys remember, the L is this transient time is depending on the tau. We say RL. If L is big, it needed more time, right? In the same meaning, in the capacitor's equation is RC. So which means if C is big, you need also like more time. Okay, let's move on. Yeah. So quickly, so it's both atoms, right? And electrifications happened like external force. In this time, something, source voltage, right? DC voltage, for example. So displacement happened, you know what I mean? So as you guys can see, if the displacement happened, actually at first time, it was neutral. But because of, displacement happened, so look at here's picture. So the minus, electrons moves, but instead the plus part is kind of heavy. So it doesn't move, totally. So which makes it like a despolarization, right? So which means that these electrons, coming through like this circuit. You know what I mean? So yeah, this is basic concept of capacitor. So first of all, yeah, you guys remember is capacitor is same material as insulator. So which means open circuit in the DC steady state. But yeah, I forget one thing. Give me a sec, guys. So look at that. What I mean is here, the charge time, right? But this is one equation have to remember. So in the C, we say I, T, dt, dv. So time goes by, if the V voltage is changing, I is, current is flow. You know what I mean? So look at here. You guys can see here slope. 1, 2, right? So which means this point 1, I will say 1, 2, 3, right? This slope is big, right? So at first time when it close the switch, the current is because of, as you guys can see, the slope is sharp, right? Compared to the others, right? So which means the current is, look at that, like this. Current is like this. So because of the I slope is big, and second is here, and third is here. And as you guys see here, we say this part is the charge part, we say transient, state, right? Instead here, look at that. Voltage is not changing, right? That's why, the current is, cannot, follow. So which means it's open circuit right now, it totally is open circuit. So which means now it's actually it stores energy. But what I mean is I'm explaining in the circuit, So and then V is not changing. So I is no changing. Here's I, current is 0. But when it discharges, we already store energy here, right? And we use it. So that's why voltage is drop down, right? So look at that. As you guys can see here, I. So you give slope 1, 2, 3. You guys see slope here. Time goes by more like this. Less sharp, right? So which means here, this current is like this. I is here minus because we use it, right? Yeah, this is a basic concept of capacitor. Yeah, physical meaning. So yeah, if you guys have any question, let me know. Today's lecture is done.